Hey guys, welcome back to math class. Well, sort of. Okay, so today we're going to take a look at some examples of independent and dependent events, and then familiarize ourselves with some terms that we need to know for this section. All right, so we've got our standard deck of playing cards here. All right, so we want to take a look at some different scenarios. So let's say that I shuffled up this deck of cards, and then I'm going to randomly choose a card. I'll just pull it up off the top. All right, and then I get a number card. Okay. So I've got a number card there, and I want to figure out what was the probability of me taking a number card out. Well, remember how many number cards there are. It's 2 through 10, all right? So that means that there are a total of 9 number cards in each suit, and so times 4 suits, so there's 36 number cards. So the probability of me pulling out a number card, all right, would have been total of 36 out of 52 or 9 out of 13. Okay, the only other options would have been an ace, a jack, a queen, or a king. All right, so that leaves 9 out of 13. All right, so that's basic probability, right? So if I take this number card and then I put it back in the deck, right? And then I take the deck and then I shuffle it, so I don't know what the next card is going to be, okay? Now, what I want to do is that I want to choose a second card. Now, when I choose that second card, is this a dependent event or an independent event? Well, since I put the original card back in the deck, all right, that's what's called replacement. Okay, so replacement means that I've reset the sample space back to the original attempt, and so now the sample space has not changed from the previous pull. So that is called replacement, when I put it back in there and reset the sample space. So since I did it with replacement, the probability of me pulling another number card is still going to be 9 out of 13, because there's still 9 numbers in each suit and 13 cards in a suit, so 9 out of 13. So if I did not put that card back in, okay, and let's say that I put that card off to the side, now it's become a dependent event, all right? So that means to say, what's the probability of, let's say, pulling out another number card, okay, given, and we're going to use this little vertical line here to say given, that I already pulled the number out on the first pull, all right? So given that I've already pulled one out on the first one, what's the probability of me pulling out another one? Now, this is without replacement, okay? So it means I did not put the card back. So this little line means given. That's what's called conditional probability. So because the probability of the second event is dependent on the first, all right? Because the conditions have changed. So now, how many numbers are there total? Well, there were 36. I took one out and didn't put it back. So now there's only 35 number cards in there. And then how many total cards are in the deck? Well, since I took one out, there was originally 52. Now there's only 51. All right. So now my probability has gone from 36 out of 52 to 35 out of 51, because I did not put that number card back. Okay. That's what's called a conditional probability. Now, if I wanted to figure out what the probability is of me pulling out 2 number cards back to back without replacement, meaning I'm not putting the card back in the deck, then I'm going to do the probability of the number card coming out in the first one times the probability of pulling out a second number card, given that I pulled one out on the first try. Okay, so that's your basic probability. That's your conditional probability. And now I'm going to multiply them together to get my final probability of this dependent event. If it was independent, then I would just simply multiply the same probability, 9 out of 13, times itself, because the probability would be the same both tries. But this one, I did leave it out, and so now we've got to multiply by the conditional probability. So this is going to be 9 out of 13 times 35 out of 51. Okay, so these are some larger numbers, so we can pull out a calculator here and do that. So we're going to multiply straight across. All right, so 35 times 9 is 315. And then on the bottom, 13 times 51 is 663. So if I wanted to just put that into decimal form or into percentage form, I would just divide those and I would end up with a probability of approximately 0.48, or about half. Okay, so there's almost a 50% chance that I'm going to pull out two number cards back to back without replacement. Okay, so let's take a look at another example. All right, so let's revisit our friends, the color cubes here. All right, so as you can see, we've got 3 green cubes, 2 black cubes, and 4 red cubes. All right, so let's pretend that we put those in a bag and want to randomly pull one out at a time. All right, so if we're talking just basic probability as a review, the probability of, let's say, taking out or grabbing a black cube. All right, so we're going to put favorable outcomes. How many different ways can that happen? Well, there's 2 black cubes in there, so favorable outcomes goes on top. Total outcomes is the total number of cubes in the bag, and that is 9. So our probability of pulling out a black one would be 2 out of 9. All right, now, if I take that black one out and set it aside, all right, now I only have 8 cubes in the bag. All right, so now our sample space has changed. So if I take another grab out of the bag, then I could say, what's the probability of getting a green cube? All right, well, when the black one was in there, the favorable outcomes was 3 and the total was 9, so it should have been a probability of 1/3. But if I took that black one out first and did not put it back into the bag, now my sample space is going to change from 9 to 8. All right, so if I did the probability of pulling a black one out first, and then I said, what's the probability of pulling out a green one on a second try, then that would change to 3 out of 8, because there's still 3 cubes in the bag, but now there's only 8 total cubes, so there's only 8 possible total outcomes. So now my probability has changed based on the fact that I took that black one out first. All right, that's an example of a dependent event, because the second outcome, or the second probability, depended on which cube I pulled out on the first one. All right, so if I had, let's say, pulled out a red one first, okay, or let's say I pulled out a green one first. Okay, so if I pulled out a green one, we said that that one was 1/3. If I left the green one out of the bag and I chose another one, now what's the probability of pulling a green out? Well, now there's only 2 in the bag and a total of 8 left. So now I have a probability of 1/4. So as you can see, these two probabilities are different because they depended on what happened on the first try. All right, if I took out a black one, then I had a 3/8 chance. If I had pulled the green one first, now I only have a 1/4 chance of pulling that green, because the initial pull changed the possible outcome or the total outcomes of the next event. So that's an example of a dependent event. Now let's say we wanted to figure out what's the probability of reaching into the bag and pulling out a green one on both the first and the second attempts if I don't put the cubes back after I pull them out. Okay, so that way it'd be a dependent event. So I'm going to say, what's the probability of pulling a green? okay, with everything in there. So probability of pulling a green one is still got a 3 out of 9, which we did before, which is a 1/3 probability, all right? Once I take that out, and the probability of pulling a green, again, there's 2 out of a total possible 8, all right? So I'm gonna say, what's the probability of pulling a green after a green on the first pull? Okay, so a probability of pulling a green after I've already pulled one green out. That's going to be your 1/4, because now there's only 2 left. There's a total of 8, so 2 out of 8, or 1/4. Okay, so then what's the probability of pulling a green on both pulls? Well, we're going to take the individual probabilities again and multiply them together, because we want them to happen in succession. All right, so I'm going to say probability of a green, then another green. Okay, I'm just using G to save space. So probability of pulling a green and then a green again. So that is going to be my probabilities multiplied together. So the probability of pulling a green on the first one was 1/3. Probability of pulling out a green one on the second one, after I had already pulled out a green on the first one, is now 1/4. So to determine the probability of getting a green on both the first and second attempt, I'm going to multiply their two individual probabilities together. And so this would give me a probability of 1/12. So my probability of pulling 2 greens out, one after another, without putting the first one back, is going to be 1/12. And so that's an example of a dependent event.